All right, here's the key for the Unit 9 Lesson 2 homework. Look at that. We got a little half circle here. We're going to have to talk about that right off the bat. This is the graph of f prime. We're asked to find the integral from 0 to 2 of f prime. We are able to find this area and all of these areas geometrically. So we're not going to approximate using Riemann sums. We're going to find the actual value. We just have to remember from left to right, above the x-axis is positive. Below the x-axis would be negative from left to right. But then from right to left, it would be the opposite. All right, so from 0 to 2, the best way to calculate this is to find the rectangle of area. It's a base length of 2 and a height of 1. And then subtract the area of this half circle. Now, this half circle is going to have a radius of 1. A circle's area is pi r squared, so that's pi. But since it's a half circle, I'm going to divide it by 2. So this is pi over 2, which I will subtract from 2. So this entire area is 2. Subtract pi over 2, and you'll get the area in black. Okay, from 0 to 4, this area right here would be 1/2 1 times 1, so that'd be a positive 1/2, whereas this would be negative 1/2. So this also would be 2 minus pi over 2. Let's switch to black. Now we start going from right to left. 0 to -3. So from 0 to -3, that's going to be the opposite of the area from -3 to 0. Now this is a good chance to use our trapezoid formula. 1/2 our base length, 1, 2, 3. And then our heights of 2 and 1. So this would be 3 times 3/2, which is 9/2. So this would be the opposite of that. That'd be negative 9/2. All right, so from 0 to -3, opposite of -3 to 0, it's negative 9/2. Let's go from -5 to 0. Again, this is from left to right, so from -5, I'll go to -4. This is going to be a triangle 1/2, base of 1, height of -2. So this is -1. This is going to be positive 1, base length of 1, height of 2, and then 9/2. So this is going to be positive 9/2. -2 to -2, from one value to the same value, that area is 0. From 2 to -5 is the opposite, and you can just write this right off the bat. Opposite of -5 to 2. So that's the opposite of -5 to 2 would be 9/2 plus 2 minus pi over 2. So I'd say that is 13/2 minus pi over 2, so -13/2 plus pi over 2. Okay, so that 2 comes into 4/2, 13/2, -13/2 plus. If you have a constant, this 2, it can just be pulled out. It becomes this. Maybe I'm not going to write that like it's a change in the question. If you have a constant inside, you can pull the constant out. We already know what the area from 0 to 2 is, so I'll be 2 times this 2 minus pi over 2. Okay, 2 to 0. 3, keep the integral the same. But then what I would do is make this a -3, turn this from 0 to 2. 0 to 2, 2 minus pi over 2, so I'll have -3 times 2 minus pi over 2, which becomes negative 6 plus 3 pi over 2. All right, now let's talk about when we're adding. It's a little bit different. This is what I would recommend you doing. It's probably different from the notes that you had if you're an 8A student, but you could either do, the area from negative 3 to 0, and then plus the rectangle worth of area, height 3, width negative 3 to 0, which is width 3, or split it up. This I can find from negative 3 to 0 is 9/2. This I can use the fundamental theorem of calculus for. I can take the antiderivative and find the change between negative 3 to 0. So that's going to be, and this is where like maybe this is not as effective as just like rectangle, height 3, width 3. So this is an area of 9. If you use the fundamental theorem of calculus, make sure you plug in the end value first minus the beginning value. That's another way of getting 9. So it's 9/2 plus 9. 18/2 plus 9/2, 27/2. This one, though, it is not a rectangle. This is just 2x. So I would split this up. I'd put a minus. And then after splitting this up, 0 to 3 I already found. 3 times 0 to 3. Oh, I didn't do 0 to 3. 0, 1, 2, 3. So that's going to be 2 minus pi over 2 plus 1/2. So 3 times 2 minus pi over 2 plus 1/2. Then minus, I would use the fundamental theorem of calculus for this. This would be x squared from 0 to 3. So I'm subtracting what ends up being 9. 5/2, 15/2 minus 3 pi over 2 minus 9, 18/2. So negative 3/2 minus 3 pi over 2. And you can combine those if you want to. Okay. All right, we're going straight from 4 to negative 5. So that's all the way down. So that's 9/2 plus 2 minus pi over 2. But I'm going to flip it. All right, so here's what I would do. And we have to be careful. Notice it's from 4 to negative 5. I'd probably immediately switch this to the opposite from negative 5 to 4. Okay? And then I'd take the opposite of all of these split up. Okay. So my first one is going to be 2 times 9/2 plus 2 minus pi over 2. So I'll just write that. Minus this guy, I need to use fundamental theorem of calculus, and it's not going to be nice. It's going to be 3/2 16 minus 3/2 25. (24) minus 75/2 48 halves minus 75 halves. 27 halves, negative 27 halves. Gross. That's what it is. I'm just going to double check that using a calculator. All right, good. And then plus. So again, you could use the fundamental theorem of calculus, but this is a rectangle with a height of 2 and a width of 9. So I think it's actually easier, instead of using the fundamental theorem of calculus, to just think of this as, a straight line 2 from negative 5 to 4. And you can just use geometry to calculate this area. Okay, so let's assume this is a free response question. You can leave it like that. If this was a calculator question, I'd ask you to simplify more. I'm just looking at if the simplification's easy. I don't think it's going to be that bad, so let's do it. So the opposite of 9 plus 4 minus pi plus 27 halves plus 18. 9 plus 4 plus 18, so that's 13 plus 18, which is 31. 31 is 62 halves. 62 halves plus 27 halves, 62, 82, 89 halves. So that's the opposite of 89 halves minus pi. So this would be pi minus 89 halves. Fantastic. What is f of 2? Now, most of you will get this wrong, but this is very, very important, and we're going to be using this for your quiz and stuff. You don't know what f of 2 is. It's an unknown. But back from the beginning of the problem, you were told what f of 0 was. F of 0 is 3. You can find the displacement of f by finding the area under f prime. It is the whole unknown equals your known plus your displacement, your change in f. So I got 3 plus 0 to 3 is 2.5 minus pi over 2. Oh no, this is not 0 to 3. This is 0 to 2. So this is 2 minus pi over 2. It's 2 minus pi over 2. So f of 2 is 5 minus pi over 2. Now let's find f of negative 5. Well, now my unknown is f of negative 5. My known is f of 0. My displacement is not going to be from negative 5 to 0. This is like my unknown ending. This is my known start. So I'm going to have to go from 0 to negative 5 for my displacement. So that's going to be the opposite of negative 5 to 0. So I get 3 minus integral from negative 5 to 0. That might be easier to do rather than plus. From negative 5 to 0, we found that was 9 halves. 3 minus 9 halves. Negative 3 halves. Okay, this goes back to, accumulation function. The accumulated areas tell us how much we're increasing or decreasing. F prime is positive, so I can see I'm going up from 3 to 3 plus 2 minus pi over 2. I'm going to go up another half, and then I'm going to go down a half. So I have a relative max here. And then we can go to the left, and I'd be increasing from left to right, but from right to left I'd be decreasing because it's the opposite. So I'm accumulating area, this would be negative. So I'd be going down from 3 to 3 minus 4.5. So I'm down at negative 3 halves, negative 1.5, just like what I found. Going down another 1, and then I'd be going up 1. So I'd have a relative min at negative 4. Okay, so accumulated areas tell us displacements. You could find this first value at f of negative 5 and see that you go down 1, up 9 halves. We'd get to f of 0 is 3. And then I'd go up another 2 minus pi over 2. I'd go up another half, and then I'd go down a half. Okay, so this is the power that we have knowing about accumulated areas. What is the average f prime from negative 5 to 4? Well, guess what? An average something, and this is something that we have to really remind ourselves of. 1 over b minus a, integral from a to b, of what you're trying to find the average of. So 1 over b minus a, integral from a to b of the something. So if I want the average f prime, I need the area under f prime times 1 over b minus a. It ends up being the average rate of change of f. I don't want you to focus on that. Just stick with this. This is fine. So 1 over 4 minus negative 5, integral from negative 5 to 4 of f prime is 1/9. Do we go from negative 5 to 4? Nope. 9 halves plus 2 minus pi over 2. I'm going to leave it like that. All right. Now I'm given a bunch of things that I know, like areas under F, areas under H, H minus G, 3G, all that good stuff. Okay, so integral from 5 to 2 of negative 3f of x, what does that equal? Well, I know what the integral of 2 to 5 is, and I know it's going to be the opposite. So I'm going to go ahead and take that opposite out. I'm going to then pull this negative 3 out, and this becomes a positive 3 integral from 2 to 5 of f. So I would write this stuff down just so you know, okay, well, 2 to 5 is 5 times 3, this is 15. You could think negative 3 times negative 5. I went the other way. Okay, here, remember 2 ways. It's either integral from 5 to 7 of f plus integral from 5 to 7 of g of 3. And this is either negative 3, and this is either a rectangle, height 3, width 2, or you say this is the change in 3x from 5 to 7, which is 21 minus 15. So either way, you're going to get 6. Your answer here is 3. 2 to 7, well, guess what? I have the integral from 2 to 5. I can add the integral from 5 to 7. Two to 7 of 3. Well, I know what 2 to 7 is, so 3 times the integral from 2 to 7 of f. So 2 times 3 is 6. 7 to 10. Okay, I'm told what 2 to 10 is. So the integral from 2 to 10 of f will equal the integral from 2 to 7 of f, which I found, plus the integral from 7 to 10. If this is 7, and I found this is 2, this must be 5. 2 to 7 have f plus 2x. This is when I would split it up because this is not just going to be a rectangle. This will be like a trapezoid. Yeah, you know, it is a trapezoid. We could use the trapezoidal formula for these. I'll show you. You don't have to. Probably safest bet is to use the fundamental theorem of calculus. I found 2 to 7 was 2. Oops, not z, 2. And then this will be, you know, x squared from 2 to 7. That's the antiderivative. That's 49 minus 4, which is 45, giving us 47. Or, since it's a straight line, 2x is just a straight line from like 2 to 7, like, we're going to look something like this. That's a trapezoid. We have 1/2 a base length of 7 minus 2, which is 5. Then heights of 2x at 2 is 4, and the heights of 2x at 7 is 14. So we got 18. I could divide that by 2, which is 9, times by 5, and all of a sudden I got 45. So I actually could go back up here, and like this 3x, I got 27 halves. I could actually done, or 1/2 my base length of 9. My heights are negative 15 and 12. So let's see. This is negative 3 times 9 is 27. That's negative 27, negative 27 halves. Here. Or 1/2 my base length is 3. My heights are 0 and 6. So this is 18 halves, which is 9. Isn't that great? All right, so when you have just like a number times x, you can actually use a trapezoid. 2 to 10 of f minus h. Well, I can split this up into 2 to 10 of f minus 2 to 10 of h. 2 to 10 of f, I found 7. It's told to me. 2 to 10 of h is 6, so 7 minus 6 is 1. 2 to 7 of g. Okay, so going off of the information I know, 7 to 2 of 3g is 12. So 7 to 2, after pulling out the 3 and dividing 7 to 2 of g, that's going to be equal to 4, which means 2 to 7 of g must equal negative 4. 2 to 7 of f plus g. Well, I know what the integral from 2 to 7 of g is. I know what the integral of 2 to 7 of f is. It's 2. Okay, so split this up. This is 2 to 7 of f plus 2 to 7 of g. 2 to 7 of f is 2. I just found 2 to 7 of g is negative 4, so this is negative 2. 7 to 10 of g. I got 2 to 7. I got 2 to 10 of h minus g. I got 2 to 10 of h. I think I can do it. Okay. Two to 10 of h minus g is 5. So that's 2 to 10 of h minus 2 to 10 of g is 5. Do I have 2 to 10 of h? I do. I have 6. Do I have 2 to 10 of g? No. But I could find it. So subtract 6, take the opposite. 2 to 10 of g must be positive 1. Okay? So that's that right here. All right, so 2 to 10 of g is 1. But now how can I find 7 to 10 of g? So I know what 2 to 7 of g is. These are probably in opposite order. Yeah, I know 2 to 7 of g. So 2 to 7 of g plus 7 to 10 of g will equal 2 to 10 of g. I found 2 to 10 of g is 1. 2 to 7 of g I found was negative 4. 7 to 10 of g is what I'm trying to find. I get 7 to 10 of g is 5. That's the answer to that. Good questions. 2 to 10 of 6h minus 4. All right. Well, it's going to be 6, 2 to 10 of h minus 2 to 10 of 4. Two to 10 of h, I found a 6. So 6 times 6 is 36. Again, rectangle, height 4, width 8, or change in 4x between 2 and 10, that's 40 minus 8. So 32 either way, and I get 4. All right, what's next? Oh, right expressions. The shaded region using both an integral and using summation notation, evaluate the integral using the fundamental theorem of calculus. I'll do the integral down here. It's easy enough. 0 to 2 of 4 minus 2x, right? Integral from 0 to 2 of x squared. Oh, you don't know how to take the antiderivative of that, so we'll go from negative 1 to 1 of 1 over x squared plus 1. Actually, you do. Oh, man, you're going to flip out on that one. No. Integral from 0 to pi of sine x. Okay, let's just evaluate them. So, I mean, we know what this area is going to be, but just to show the fundamental theorem of calculus, take the antiderivative from 0 to 2. 8 minus 4, which is 4. This is 1/2 base length of 2, height of 2, height of 4, so that's 4. Here, we've done this enough. We know that it's not going to be 4. It's going to be 8/3. What is the antiderivative of 1 over x squared plus 1? Well, if you remember the derivative of arctangent, you actually know the answer to this. Now, arctangent of 1 minus the arctangent of negative 1. Do you know that? No, you probably don't. I don't want to stress you out about it. But, like, I believe I know the answer. Yeah, take the tangent of both sides, you get 1 equals the tangent of x. And it's like, what is x when tangent equals 1? It's pi over 4. Negative 1, you could say this is negative pi over 4. You could say it's 3 pi over 4, but the area is positive. So I think they want negative pi over 4, giving us an answer of pi over 2. You're actually allowed to leave your answers, including the arctangents like that. So I don't want you to kind of stress out about that, but it isn't that hard to find. Antiderivative of sine is negative cosine. We've done this one before. The area under a hump of sine ends up being 2. So this is 1 minus negative 1. That's 2. Okay, done with that. Now, here's how we do the summation notation. We will have an infinite sum of a bunch of heights times widths. Now, the x sub i's is a starting point A plus a multiple, comes from I, of our delta x, to see like how many times do you go over to the right to find our function values. Delta x, remind you, is b minus a over n. It's the width of a subinterval. Okay? So I'm going to start off, and I'm going to say, okay, limit n approaches infinity of sum I starts from 1 goes to n of f of a plus I delta x. A is 0. Delta x is 2 over x. 2 over n. And then delta x, 2 over n. Then the last thing I'm going to do is replace f with what f is equal to. I'm going to replace this for x. So I starts at 1, goes to infinity of 4 minus 2 times 2in times 2 over n. And you can simplify that further. They probably would want you to do that. 8 over n minus 8i over n. So 8 minus 8i over n. Yeah, maybe not. All right, here, limit as n approaches infinity, sum I starting from 1 going to n, f of x sub I. Okay, x sub I in this situation is 0 plus I delta x. So 0 plus I is I. Delta x is 2 over n as well, because the width is just from 0 to 2. And delta x is 2 over n. F of x is x squared, so this turns into limit as n approaches infinity of the sum I starts from 1 goes to n of 2i over n squared times 2 over n. You could simplify this to be 4i squared over n squared, 8i squared over n cubed. All right, this one be a little bit more interesting because a is not 0. Limit as n approaches infinity of a sum I starts from 1 going to n of f of a plus I delta x is also 2 minus n because it's 1 minus negative 1. Okay, but then f is 1 over x squared and this would be my final answer. I'm not going to want to simplify this at all. And then this guy, it's nice that a is 0. Delta n is pi over n. Delta x is pi over n. This is f of, so this would be the sine of I pi over n times pi over n. There actually are ways to evaluate these and evaluate this one that we're not going to spend any time doing because it's kind of pointless because of the ease of use of the fundamental theorem of calculus. Areas are equal to displacements of antiderivatives. Like area under velocity, change in position. Area under F, change in big F. Area under F prime, change in F. All right, so I guess relatively short homework compared to some of the more recent ones. Hopefully we understand this. Let's see you for your quiz.